Hey everyone, it's really fun to be here. This is my hometown. I grew up in Austin, Texas, and I don't get to come back often enough, so it's a great opportunity to be back and share this new technology with y'all. So if you're not yet familiar with FaunaDB, it's a new adaptive database, and what I'll be talking about in this talk, is how it fits serverless like a glove, but I don't want to just tell you that, I want to show you, so we'll also look at some application code. I'm the Director of Developer Experience at Fauna. That means I focus on what it looks like to pick it up and use it for the first time, and is the tutorial that you want the first thing that you see right when you think you need it, and all that kind of stuff, because if someone's going to pay attention to your product, you want them to have those successful moments right away. It's super important to have smooth on-ramps for developers because, developers can tell if we are, if a particular vendor is respecting your time and attention. And so having, a focus on that developer experience, I think, is really important for, technologies that hope to have a lot of adoption. Previously, I was the architect of the Couchbase mobile product, which is offline and edge compute databases running on phones and IoT devices. And you can find me on Twitter at jchris. Ask me questions there if you can't catch me after the talk. So how many of y'all are familiar with the To-Do MVC example suite? So for the rest of you, what it is sort of a standardized to-do list application, the purpose of which is to show off the various front-end frameworks. So you might have one in React and one in Angular and one just using jQuery. And they all look the same. And I thought, hey, I want to do like a canonical example for this conference talk. I want to write code where people aren't going to have to learn much to keep up with me. So why don't I go grab To-Do MVC? Surely there's got to be one that talks to like a REST backend that you log into. I'll just find that one and make it so it talks to my REST backend. But the best I could find is this Reddit thread that says, if you decided to do a to-do list app again, please give it a backend with user auth and persistent storage using database. So that's what I did, and I'll be going through the code of that to-do MVC example in this talk today, especially with a focus on FaunaDB's security model and how it allows you to do the database integration pattern so that your Lambda functions don't have to be so, walk a tightrope as far as security. So the agenda again is, first, why is FaunaDB the first serverless database? That's a big claim in a world where people have been doing serverless for a long time and FaunaDB hadn't been out yet. So I'll talk about that. And then we'll go look at To-Do MVC and we'll look at the architecture of it. Specifically, the way I wrote it is designed to be production style so that if you were to take these individual components, you could use them in your production applications. And then we'll do a quick demo. And part of the demo, you'll get to see a little bit of the user experience of FaunaDB. So there's two slides here about why FaunaDB is the first serverless database. This is kind of the table stakes. You're going to see other databases that implement these bullet points. And then we'll go to the next slide where we're really breaking new ground. So of course, a serverless database needs to run in the cloud. Now, we run on multiple vendor clouds, and that's going to help you avoid vendor lock-in and be able to move your data and your compute to get better price or to get locality to features that some of the cloud providers may have that others don't. So FaunaDB managed serverless cloud runs in 5 AWS regions and GCE right now, and we're adding Azure just as quickly as we can. We have a feature on the way also called dynamic site selection that lets you pin your data to particular data centers so that you can have, you only pay for the replication you need instead of replicating worldwide. The data model is again also a 2017 data model. So your objects you store can look like JSON. They can be deeply nested. But we're sort of more interesting than that. So you can go store your JSON and kind of not worry about it, or if you want, on the way in, you can tag particular fields in your objects as being references to other objects, and you can do joins, and you can do uniqueness constraints on indexes and the things that you would expect from a relational database. So that kind of gets to the heart of the data model of Fauna. It's a non-tabular relational database with global distributed transactions. So what that means in terms of history is that back in the day, like maybe 10 years ago when I was starting out, you would write your application against a database, and you didn't have a choice. Your database was going to be like MySQL or Postgres. And then when you got popular, you also didn't have a choice. You were just going to crash and have a fail whale. And so since then, the NoSQL movement came along and gave you some choices. You could say, well, I want to be able to ride that adoption curve as my my app goes on television shows or whatever is going to take down your backend in the old world. And so we'll use this NoSQL database, and we want to stay up when the Super Bowl ad runs. So it's worth it for us to have to deal with quorums and kind of all the data model compromises that NoSQL asks you to make, especially the lack of transactions. But what we've got here in FaunaDB is all that stuff you had to give up in in that transition. You get it back now, and so you have the distributed transactions, and you have the foreign key constraints, and you have everything they said you couldn't have at scale. And that's because we're built on a new distributed consistency protocol that's only come out of academia in the last few years. So there are going to be more of these globally distributed, strongly consistent databases coming out in the future, I'm sure. But yeah, I guess the lesson here is you get to use a real database. Now, the core data model is temporal. That means that when you update an object, it keeps the old version of it around for, you can determine the garbage collection time period on a per class basis as you're setting up your schema. But what that means is that you can easily ask the database for what's happened since the last time you told me, the state of this query or these objects. And the temporal features apply not just to the individual instances, but also to indexes and queries. So you may have like a complex query that returns a big data set, and you really just want to put it in event mode and grab the new stuff. So it allows you to do cache coherency on secondary index systems or mobile devices like that. And we have on the roadmap the ability to trigger Lambda functions with that same history. So getting beyond the table stakes, what sets Fauna apart? And we'll focus on this object level security today. So you get to model your business rules in the database, and that used to be popular again back in the day before you had to drop Postgres in favor of scale. And we'll talk about how that fits really nicely with serverless, because you can actually have your lambdas run with their connection to the database having only the privileges of the current user. So there's a couple of other important points. How many people here have ever under-provisioned their DynamoDB tables throughput and had your app fall on its face when it was supposed to be popular? And so all the hands that didn't go up, those are the people who over-provisioned, and they're paying for database they don't need. So we don't have that. Instead, you just pay for the actual requests that run and the actual storage that you store. This makes it, mostly just so the database becomes even less of something you have to worry about. You don't need to anticipate that your site is going to become popular. Now, there's also this hierarchical multi-tenancy, which I think is really neat for the low maintenance aspect of serverless, where deploying a new service is not a heavyweight thing to do. And so, for instance, this would allow you to have a business process. Like, let's say your app is something that hotels use for room booking, and you sign up a new customer, and so you want to spawn up some databases, like maybe one for the customer, maybe one for each of the hotels in their chain. And you could just have a Lambda endpoint that hits a couple of APIs on FaunaDB, and now you've got databases that are automatically in the tenancy tree in a place where their quality of service is going to be managed based on that customer's quality of service, etc. We also, on every response, if you look at the HTTP headers on the response, there's the number of points that that query cost you. And so you can use that to do build through to your customers if you're interested in that sort of thing. And the last one is kind of a minor point, but I think it's a developer experience point. If I go start looking at the way folks are using databases with Lambda, I see a lot of like, I don't know what broke, and then it turns out the thing that broke was some kind of connection pooling that's basically irrelevant for the Lambda use case anyway. So our client is stateless, it speaks HTTP, and that means that you're not setting up a connection pool and then throwing it away. You're just making requests. So now let's switch gears a little bit and talk about the to-do MVC example and the architecture that I used, and maybe a little bit of how it's an architecture that you would be able to use in your app, even if your app is more complex than this. So the content service, I guess I'll just kind of do the glossary first. The content service is what I usually think of as the app. And I had to learn this content service term when I was learning serverless, but back in the days, this is a thing that lived in the Rails directory, and it knows your domain model. It knows about users or blog posts or recipes or to-do lists or whatever. And that can be arbitrarily complex and query lots of different backend APIs for storage if it wants to. Now, I think this is maybe like if there's a take-home message from this talk that's just going to make you more productive next time you go write a serverless app. There's this authentication boilerplate that I'll link to later that is, it essentially gets you logged into the app, and that code is similar enough on enough projects that it's better just to reuse the boilerplate than to write one from scratch, even if you do have to make some small changes to it. And then the last component here is this custom authorizer, and we'll see it in a picture so you can get a sense of the data flow in a minute. But the custom authorizer is part of the authentication service, but at runtime, it acts as a proxy over the content service. And so what happens is the authentication service, after it logs you in, it gives you the token, the JWT, that corresponds to your login secret for API gateway, but it also attaches a payload to that. And in the payload is a FaunaDB access token that's specific to the current user. So the custom authorizer unwraps all that and hands it to the content service, just as a string the content service can use to instantiate the client. And therefore, the client is only acting on the database with the permissions of the current user. So the front end is where all the integration happens. It's the session glue. It's the one that sends the password, sends you over to Facebook. It takes the token and sends it back to the authentication service, and takes the authorization header and sends it to the content service. So without the browser code, it gets to be pretty hairy to try and debug this in curl or something. So we're going to look at some code in the content service, but before that, I want to just kind of like step through the lambdas that we'll look at so you have a sense of the context, and then I'll flip over to the editor. So creating a to-do item is relatively simple. You just take the text and assume that it's not completed yet. And where it gets interesting is that on the way in, we tag it with the current user so that the current user is the only person who can modify that item or read it. The read all to-dos is deceptively simple. I've written it using security naive code, so it looks the same as the code that would return everybody's to-dos. But because FaunaDB automatically applies the access control model on the way out, it just returns your to-dos. Updating to-dos is where we'll get to see a little bit of how you can reach inside of an object and just change one of its fields. And then toggling all is similar to reading all, in that it relies on the access control system to mask you to the correct set of to-dos, but then we can see how we're flipping the completed bit on all of them. So here is the create function, and we don't need to worry about the whole thing. Kind of the interesting bit here is the query, and let's see. I'll unpack this for you a little bit. the first thing to understand is that what gets passed to the client when you issue a query is an abstract syntax tree that is built by these functions. So all this other stuff is query builders. And that means that when you get me here, what this really is just like a stanza of fauna query language that refers to the current user. And so I stuck it in a variable, and then I'm going to use that variable actually on my object so that the object can refer to the current user in the userland data space. But then I also use that variable as the read and write permissions on this object. So I'm getting myself, and I'm attaching it to what gets written in 3 different places. I guess I should point out, data comes in, it's just some JSON that gets parsed off the wire. The read all, again, I said this one's really simple. I guess there's a couple of fun things you can learn from this. So what we're doing is we're paginating over all the to-dos, and it's in here that the access control is applied. So the result from this is just going to be my to-dos. And then what gets to be interesting about it is that we're doing a loop over the result set. So the result set of this is just going to be an array of references. So then what we're going to do is loop over the references and actually fetch the record that corresponds to the reference. And that loop executes on the server. So again, this is all compiled by the query builder into an abstract syntax tree and sent as the query over to the server, which executes it all and sends the result set back. So it's a very simple one, but you can see how this could get more complex. There's if statements. You could do branching inside your loops, so you could do different kind of fetches depending on things. And all that runs inside the transaction. So here's where we're doing an update. This is a very simple one. We're just updating a single to-do that came out of the API gateway path. And we're just setting the completed as the one that came in from the JSON parsed and giving the opportunity to change the title. So again, this query would fail if you didn't have the right permissions on that object. And toggle all is kind of everything we've talked about put together. So we're looping over all of my to-dos, and we're running an update where we're fetching the current state of that to-do and flipping the bit on the completed. You can see here that we use this data path, key path syntax to drill into the object. All your user data is inside the data envelope. There are other top-level fields. There's a timestamp that we use for the temporal tracking. There's the class that you're a member of that we use for applying the access control, etc. So you don't have to worry about the difference between metadata and data. You just do your work inside of the data envelope. And I suppose people ask sometimes when I show them this app, like, what's going on in your serverless.yaml for configuring the database? And there's no mention of fauna in my serverless YAML here. There is, let's see if I go. Yeah, there's nothing, nothing in there except for this authorization ARN. And so that gives us a chance to drop into talking about the authentication boilerplate, which gets to be a little bit more technical than the content service itself. And we'll come back to that in a second, but the what we're talking about is the authentication boilerplate has a privileged secret, and it's able to pass that privileged secret into the content service via the API gateway payload. And so the content service doesn't know anything about connection secrets for FaunaDB except for that it should parse it out of the request context. So that allows for a single authentication service to dole out secrets to lots of content services, for example. So let's take a look at this authorization service and just kind of get a sense for what's going on there. So you've got the browser. It talks to pretty much everything through the API gateway, and this is this is kind of the status quo before FaunaDB. So the user service talks to some database, and the content service relies on that determination of the user service to figure out what else it does, but there's no database integration. So with Fauna, we can move to a database integration pattern where the content service and the user service are both talking to the same database, and it allows the database to be security aware. So how many of y'all have taken a look at Serverless Authentication Boilerplate? I found it because it was linked prominently in the Serverless README. But I would really recommend, if you're going to stand up an app, especially something from scratch that you don't already have authorization on, use this. Implementing auth is step 0 of 80% of apps. So go ahead and do it the right way. It has options for the user service database and for the cache database. Basically, you can use FaunaDB or Cognito or DynamoDB out of the box. And out of the box, you probably won't have to change any code except for maybe like uncommenting a line here or there to get it configured right for your application. So, yeah, it's a big time saver. And by the end of this talk, you're going to understand it really well. So this is, we have 3 sequence diagrams here that walk through everything that happens in the authentication boilerplate. So the first thing that happens is the browser hits this sign-in lambda. And the sign-in lambda kind of looks at some local config and says, oh, for this app, we want to do Facebook. So it redirects to the Facebook endpoint, which if you've already approved the app, just redirects back right away. Or if you have to do something in the UI, then you maybe log in. And it redirects you to this callback service. So it's essentially the Facebook callback, which then talks to FaunaDB to find or create a user corresponding to your Facebook ID. And FaunaDB then returns a database secret for that user, which can only access the database with that user's permissions. And the callback puts all that together into an authorization header with a payload that's compatible with API Gateway. And we move on to the next step. So here's sort of like normal operation. This is what smooth sailing looks like. Your browser makes API request to the content service, which the authorizer intercepts on the way in and parses, validates the policy and parses it out so the content service can access FaunaDB, using the correct secret, and then the content service returns the API response to the browser. So, essentially, you just write this code and you connect to the database in the correct way. And the rest of this, you don't have to worry about much. Now, that's all well and good until your session times out, and there's a refresh loop in the system that sort of, it allows you to bootstrap your session back up after you've had some inactivity. And so this comes into play when the browser makes an API request, and the authorizer lambda says, and you get access denied. And so the browser, this is, again, some integration glue that's in the JavaScript of that to-do MVC. Anytime it sees access denied, it thinks, oh, probably I just need to refresh. So it uses the refresh token that was sort of appended onto a response earlier to talk to this other lambda whose sole purpose is just to turn refresh tokens into new sessions. And so because of that, it's not sitting behind an authorizer. You just have to have essentially a one-time key to access it. So we take the token, we go look the user up in the database, we set up the session again and set the authorization header, and now we're back to normal operation. So if you've ever written an auth service, it was probably about that complicated anyway. And you may as well use one that other folks have been working on. So we're going to pop over to the demo now so you can kind of just see what we've been talking about a little bit. And the first thing I'll do is log in with Facebook. And I've already approved the app, so if the Wi-Fi is willing, eventually we'll be on the other side of this. And now it's loading my items, and oh yeah, I remember I was getting hungry earlier, so we can check that off. And because it's a demo app, the way that I'm doing the repaint is I change the database and then I query for everything again in repaint. So it could be faster, but that's the basics of it. I suppose what's interesting to note is that there's lots of items in there that aren't mine, right? So we're not able to access them here. Here is a view via the dashboard. So now we're inside the FaunaDB web UI of some random instance in the to-dos database. So some other user has something called Smile in their list. And we can kind of go back and see all the instances in the database. So you can see there's a lot more items than just the ones, and this is just the first page. So anything that didn't show up on my screen is stuff that got masked out by the security model. And while I'm on this screen, I know some of y'all have already entered to win the Amazon Echo that we're giving away. But if you didn't enter the raffle already, it's super easy to do. All you have to do is sign up for fauna.com. So you can go on your phone right now to fauna.com and click Start Free Trial and put in your email address and click Launch My Database. And if you only click it once, it works better than if you click it twice. Because if you only click it once, then it'll redirect you eventually into the database and you get to play around in there. So we'll have the drawing sometime probably before lunch tomorrow. So yeah, go ahead and go to fauna.com and sign up. And the next screen will be, I can just do eventually it'll load up that dashboard that we saw over here, but an empty version of it, and you can create new databases and create indexes or whatever. So we don't actually need to wait on that, but that's what you can expect is that the goal is within 60 seconds of developing the intention to use Fauna, you're actually in there interacting with your data. And there's a little quick start that will mean you don't actually have to read the documentation, as well as links to all the documentation and drivers. So of course, everything that I did just then was in JavaScript, but we have support for basically every programming language. And we maintain our own drivers. They're all open source. When community people come up with a new driver, then we usually adopt it or something, or use it as inspiration for that language. So, yeah, go to the site and download drivers and have fun with it. I'm going to go ahead and jump to the last slide and put these links up for y'all. And I've got a few minutes for Q&A if anyone's got questions.
Yeah, I got a question. So how do you handle if a user has access to like a team to-do list?
Sure. So the data model for that sort of thing is you delegate the access. And so you would end up creating an object that represents the team, and the team has access to all the items, and then the team also delegates its permissions out to its users.
So you're able to do both the team and the user level permissions that way?
Right, and then the objects could have team IDs and user IDs on them. Okay. Question? Right. We don't have WebSocket support yet, but it's on the roadmap. It's probably the way that we'll implement the event push to trigger lambdas as well. Question? Yes, I didn't even mention that, but so what sets us apart from other cloud databases, one of the key ones is the ability to do distributed global transactions. So you can have a transaction that mutates multiple keys, and then have that show up in an all or nothing way in all your data centers. Question? Oh, it's called the Calvin protocol with a C, and there's a blog post on our website that goes into how we use it, etc. So there is no schema in that sense. Having fields on some of your JSON documents that are on others is expected. The schema shows up when you want to do access control or when you want to build indexes. So if you had a new index that was on a sparse field, you would just define that index and it would find the records that had that field. Question? Like technically we can, but it's not really a public API, and there's not really a good reason to unless you have latency sensitive writes. We're tuned for throughput on writes, so you're still going to get great write performance. We don't have any built-in integration like that. You'd probably end up writing lambdas to connect them. Oh, yeah. Sure. The best way for me to think about those is in terms of the big features that are on the roadmap and the adjacent use cases that'll get us into. So right now we don't have the push model for events. The actual data model is event-driven, and so when we do get the push events, it'll be richly integrated. The ability to have events coming off of individual queries, not just off of predefined collections or records. And then the other feature that we'll be adding, hopefully sometime this year, is analytic queries. So, the ability to do roll-ups over time segments and power your dashboards and stuff. Yes, so you're always talking to it over SSL. And then data at rest, I'm not sure what we do there. You can come talk to Ed at the booth after this. Well, thank you. Thanks a lot.